All right, I know people are still trickling in, but we're going to get started here. Welcome back to Identity at Scale. My name is Greg Smith, and in today's sessions, we're hearing about some very interesting use cases dealing with large populations of identities. You're bound to notice a recurring theme of automation, avoiding downtime, adapting to cloud-hosted models, and staying cost-effective. Next up, we have Josh Reddick and John Barton. Josh is a hands-on technology enthusiast with Mannheim, the world's largest automotive remarketer. With more than 20 years' experience in software development, he has a broad-ranging background across numerous programming languages, too numerous to mention. Recently, he has been delivering public-facing APIs to empower new applications in the auto industry. John, an advisory software developer for Cox Automotive, has over 2 decades of experience in the field of software development, during which he has been involved in the creation of many solutions for the automotive remarketing industry, including real-time auction systems, web-based search tools, and mobile apps. Recently, John has been focused on creating and securing public-facing cloud-based APIs for the automotive industry. Gentlemen, I turn it over to you.
Thank you, Greg. I'm Josh. I was going to talk about myself for a little, but Greg took care of it for me, and this is John. So I'll just we can just go into the slide. Greg also mentioned we both work for Mannheim, which is part of Cox Automotive, the world's largest auto remarketer. We're used car salesmen. We sell a little over 3 million cars a year. We use PingFederate to provide OAuth for our api.mannheim.com, our public API platform. We're getting about 900 million API calls a month right now on the platform, and we're part of Cox Automotive. Most of you are probably more familiar with AutoTrader, Kelley Blue Book. Those are also part of Cox Automotive, but we think we're cooler. So why automate your deployments? We really automate everything so that you have 100% repeatable, you can roll back, everything's just kind of automatic. We run in the cloud where the servers may not be around for very long. Amazon likes to come along and kill your server and replace it with a new one because of some security patch. My boss says treat your servers like cattle, not like pets. No offense to anybody that had a pet cow. Come on, you're supposed to laugh. We also need to automate to scale. We scale up in the middle of the day, scale back down at night. The auction business is still a very physical business. We run physical locations around the nation and around the world. And they're very brick and mortar still, so we get a lot of traffic during the day. We not so much at night. We don't get nearly as much traffic on the weekends. Turning servers off saves a lot of money. And lastly, the biggest source of downtime is us and you. So remove it and replace it with robots. So how did we define success? Well, don't fail, okay? So any downtime, we strive for 5 nines of availability. Any human task during deployment is a no-no for us. So if we have to log into the admin console, we're in trouble, something's wrong. Having to be awake for it, I don't like staying up late anymore, I'm too old for that. And having to tell our users that we're going to have maintenance and something's not going to be available. We just don't like to be there. So if you're not familiar, what's Elastic Beanstalk? AWS provides a ton of services. Some of them are big, some of them are small. EC2 is computing, ELB is load balancing, S3 is file system, and they've got all these little bits. Elastic Beanstalk groups a bunch of stuff that's very common together for building a web-based application into one kind of thing that you can deploy together and manage as a group instead of having to manage each of those little components individually. And with that, I'm going to turn it over to John, and he's going to talk more about how our EB apps work and how our ping works.
First, we want to start out by taking a look at what our PingFederate clusters look like deployed out to Elastic Beanstalk. We deploy PingFederate as a standard Elastic Beanstalk application using generic AWS EC2 instances, but we do split the application up into 2 separate components or environments, the runtime engine and the administrative console. The reason we split it up into 2 different components is so that we can deploy the same deployment package out there, but have a separate configuration, scaling policies, EC2 instance types for each component. We use RDS for MySQL, which is where PingFederate stores the OAuth 2 clients and persistent grants. And we also use S3 storage for clustering, discovery, and management. management. It's listed down here under Elastic Beanstalk. Technically, RDS and S3 aren't part of Elastic Beanstalk, but you can reference them from your Elastic Beanstalk apps. So that's still included here. Next, I want to talk at a high level about our deployment pipeline and some of the tools that we use in our pipeline. We'll go into some of these in a little more detail in the upcoming slides, but everything for us in our pipeline starts in GitHub. We automatically start a build whenever there's a commit. We use a continuous integration tool called Circle CI to orchestrate the build process, a tool called Bundler to configure the build environment and make sure it's consistent, and we fetch non-source code dependencies from Artifactory. And then we use a tool called Rake and embedded Ruby templates to customize some of our build and templates that are part of our configuration. When we do the actual deployment itself, we use an open source tool called EB Deployer that was created by ThoughtWorks, which uses the Elastic Beanstalk APIs provided by AWS, but it adds some additional features on top of that, namely blue-green deployments. We'll do the blue-green swap on success, and then we send out notifications when the deployment completes, whether it was a success or failure. So to deploy something out to Elastic Beanstalk, the first thing you need is a artifact or a deployable to deploy. So we do that by creating a custom PingFederate deployable. So we have the off-the-shelf version of PingFederate, the zip file stored in Artifactory, and our build grabs that out of Artifactory when the build starts, and then we add a couple of things into that zip, including JDBC drivers, some custom PCVs and data stores that we've created for our needs, agents for some of our monitoring tools like New Relic and Datadog, some static configuration files such as license files. We have some configuration files that are dynamic per environment, like PCVs and data stores. We process those with embedded Ruby templates. The values for those templates come from configuration files, and we also have some more sensitive data, like database passwords and such, that come in from environment variables on the CI box. So once we have a deployable ready to deploy, the next thing that we need to do is set up the runtime environment. Elastic Beanstalk uses a configuration file. It's a JSON file. It looks similar to a CloudFormation template. It lets you define everything about your environment, from the platform that you're going to run on to your scaling policies to your SSL certs. It's a JSON file, and it's kind of verbose, and it's not very human readable. One of the things that EB Deployer adds on top of that is it adds YAML files that are a little more succinct. So we have templated YAML files for EB Deployer so that we can substitute things in, like for some of our lower environments like QA, we use smaller EC2 instance sizes, different database sizes, etc. EB Deployer also lets you pull in additional CloudFormation templates for other things that you're going to reference in your application, such as RDS. So we use a CloudFormation template for our RDS stack. And we also include what are called EB extensions. They're files that Elastic Beanstalk lets you include as part of your deployment. They'll run when the EC2 instance is starting up before your application is deployed, and they let you further customize that EC2 instance. We use EB extensions for customizing the network stack on the box with some performance recommendations that Ping has made, and also for sending our syslogs or syslog traffic to our log aggregation service and configuring some of our other monitoring agents. So once we have all these things ready, we ship them up to S3 to prepare for the deployment. When we get ready to actually make the deployment happens via EB Deployer, and our deploys are started whenever we change our custom PingFederate components or there's a version upgrade of PingFederate. Every deploy that we do replaces the entire cluster with a new one. We know that this means that we lose some of the state. Access tokens are somewhat volatile anyway, so we've kind of prepared our clients to expect tokens to expire unexpectedly sometimes. We always deploy the admin console first because it needs to be up and available for the engine nodes to register themselves. And we use separate S3 buckets for each one of our clusters. We have a different bucket for the blue environment and the green environment so that when the nodes come up, they don't register themselves in the wrong cluster. Another thing that the EB Deployer tool provides is the ability to smoke test things. So we have smoke tests that run on our deployment for each component that actually do things like they actually request tokens and perform other tasks within Ping to make sure that the instance is good before we do the CNAME swap. smoke tests all pass, we do the DNS CNAME swap, and if anything fails, we bail out on the build and stop right there so that the existing cluster continues to work. But if everything goes well, after a cooldown period, we deactivate the old cluster so that the old EC2 instances are cleaned up. Josh is going to come back and talk about monitoring.
So now we're able to automatically deploy PingFederate out to AWS, and that's about like 85–90% of what you need. Monitoring and auto-scaling are really the other ones because we want to grow. We don't want to pay for instances we don't want to run. It'd be so much easier if we didn't have to worry about how many instances we were running, how much they cost. You could just go build a bunch and let them all sit out there and run, and you're happy. But in AWS, they charge you for every minute a CPU runs, so we don't want to do that. You can't really have good auto-scaling without good monitoring, so they kind of go hand in hand. There's a million tools out there for monitoring and visibility into your applications. We know we pay for most of them. So we do things like instrument all the VMs and JVMs with New Relic, get you good transaction level data, get you good visibility inside the machine. We use the CloudWatch alarm straight from AWS. We generate synthetic transactions using AWS Lambdas to make sure that we're constantly generating tokens, that everything's available. We aggregate a whole bunch of stuff together using Datadog that gives us good visibility, lets us send out alerts, good visualization. But in the end, that really all feeds back into information that we use to make the decisions, and then we turn around and actually use CloudWatch to trigger auto-scaling, scaling up and scaling down. You can trigger off of things other than CloudWatch in Amazon, but you have to write webhooks and kind of stuff and do it all yourself. Doing it with CloudWatch is way easier. What we found is that we scale actually on network out. While a lot of security stuff, a lot of SAML and OAuth token signing and everything is very CPU intensive, we've found time and time again that actual network out in bytes is the easiest, most reliable way to make a judgment call. Then the really important things to know about scaling in Amazon, you kind of got to be ahead of the curve. I put in an earlier slide that we scale in real time with some quotes around it. Scaling up in Amazon in EB, at least, takes 2 or 3 minutes to add an instance. So if you wait until you need it, you're too late. So you got to make that judgment call early. On the other side of it, you can't slow down too quickly. There's this thing that we call instance flapping. So if you spin up quickly and then you decide, oh, you're right at the edge and you might want to bring it back down and you pull that instance out, well, Amazon's going to charge you for an hour every time that you bring up an instance. So if that instance ran for 2 minutes, you wasted 58 minutes of CPU. So you got to be careful that you don't cool down too quickly. And so this is a time-lapse video. We were going to be super, super cool and kick off a build at the beginning of the talk and let it run in the background and then swap it back over to it and, say how cool we are. But our build process right now is taking about 25–30 minutes, which is longer than the presentation. That's mostly waiting on EC2 to do things. I recorded a little time-lapse video that'll sit here and run. John makes the joke that what we do for a living is wait for that box up there in the top to turn green, because that's what a lot of our life is. Questions?
Thank you both, gentlemen. That was excellent. Personally, I'm hoping my team will leverage some of what you've done when I get back home. But before you open up for questions, I have to remind everybody this session is being recorded, so please put your hand up and I will bring you the microphone so we can hear your voice for posterity. And here I come.
Hi, folks. We actually do something very similar. We use Packer, but we automate our deployment as well. And one of the challenges that we've seen, actually there's 2 challenges with PingFederate. One is the crosstalk. As you scale up and you replicate state across the nodes, it's pretty chatty. How did you guys deal with that? And then 2, I'll ask the second question. We run hot across regions. And so we basically shard our load into the regions based on latency-based routing. Do you guys do anything like that? And if so, how did you deal with that latency? For the first one,
while we're really extremely high on API calls at Mannheim and Cox Auto, we're a little probably on the lower end of the number of like external clients and tokens that we generate. So we're not at, in the last presentation, if you were in here for that, there's kind of a tipping point of where you, as you that synchronization of state across your entire cluster makes your performance start to go down. We're not at that tipping point yet. So when we get there, we'll start to have our runtimes as a cluster, and then a separate cluster of state servers that will sit behind it to help maintain that state. We're not there yet, but we hope to be. For your second question, the answer is we punt, we don't. Our engineering, we're basically located in AWS East today, so we're not multi-region with this application, which is funny because our front door load balancing is geo-located, so it actually will bounce you through west and then back to east. And that's actually intentional. We've looked at it. Our overall engineering kind of department is doing a lot of work around our multi-region hot at the lower level below our application. So we're kind of in a holding pattern waiting on them to finish that before we go multi-region with this application.
Is there a reason why you call this as Beanstalk? Because it's more of an EC2 and ASG launch config kind of thing, right? So just wanted to know. Could be a reason.
Was that why we went with Beanstalk versus just straight EC2? Yeah, so one was comfort level. We probably have a couple of thousand EB Elastic Beanstalk instances running at any given moment in the dev account, and probably more in the prod side. So we're very comfortable with EB. A lot of the one of the things, your crosstalk for your state synchronization is very easy to manage through security groups, which are kind of part of Elastic Beanstalk. So it's kind of like one of those things where Elastic Beanstalk gave you the ELB, you could configure it for SSL termination for you, it kind of included almost everything you need except for, this one little bit, so you just bring in a CloudFormation template for that.
This row.
You three should have sat in the front.
Question, I'm not sure, have any support for Dockers and in your plan? And we also plan to also maybe about to kind of using Docker as kind of as a mutable image or something. Is there something you're also in your plan as well?
So we've run some stuff on Docker. We do at Mannheim and Cox Auto run applications on Docker. We're not running PingFederate on Docker right now. We're deploying basically deploying one EC2 instance with one application on it. And so a lot of the benefit of Docker is lost on us, if that makes sense.
Hi, how are you managing the database aspect of it in your blue-green deployment? Especially if you're using it for persisting OAuth grants.
So the database itself is created with a CloudFormation template, so it doesn't change between deployments. The database itself is persisted across deployments. The actual database schema itself, we use, on one of the earlier slides, you probably saw a rake task in there, DB migrate. We use some Ruby tools for doing database migrations, so we have a database migration in there that created the initial schema from Ping for the database. But the database really doesn't change between deployments, and the data just persists across deployments. What's that?
How do you move your data across? You have a live environment which is using a database. You are testing in another environment, and you want to move your traffic there. All your refresh tokens are in the live environment right now. How you move that across?
So we have separate environments for QA integration and performance and production, but we don't move any data across them. Like every environment has its own, like the configuration is built and stays the same for each environment.
I think my question was more within the environment, when you do the swap, basically.
Are you asking between the blue and the green
Yes,
as we
yeah.
do the swap? Yes,
Yeah.
yes. So during that, we'll actually be using the same database underneath for that swap piece of the swap. So the refresh tokens and your persistent grants and everything, that state maintains because we reference the same DB instance
So you
or
can
DB
have,
cluster.
so when you have PingFed upgrades, the schema might change and things like that. You can have two versions of PingFed actually talking to the same database, two clusters, two versions at the same time?
So we haven't hit a problem with it yet. We have a mitigation strategy. I know. But we've hit this. We have another application, and we just actually went through this. And so the mitigation strategy is your one deployment turns into 4 deployments. So we like to deploy a lot. So you first do a deployment that migrates your data that will work with either version. Then you upgrade to it talking both versions. And this is generic, this is not necessarily just ping. Then you make another deployment to deprecate your old code that no longer needs the old schema. Then you make the 4th deployment to remigrate your database. So it's a very turn your key, sir kind of operation, but that's one of the very few ways to do it and maintain uptime.
But that's a lot.
We like to deploy a lot.
So my understanding is when you add servers to the cluster, you have to restart the remaining servers when you add another node. How do you manage that on a daily basis?
So the deployment we're using JGroups for the cluster management. So JGroups uses a file-based, and we use it and we write to an S3 bucket. So as instances come up, they register both with they can talk to the admin console, they can learn from JGroups what the other nodes are, and so they can add and subtract themselves using JGroups. You do have to maintain 2 buckets because when you're doing the blue-green part, those need to be kept separate. So you have a blue bucket and a green bucket, and they all register in, and then you do the swap. But adding and subtracting from one cluster is taken care of with JGroups.
Time for one last question, if any, I knew it.
So obviously, PingFed is all made up of these configuration files, these XML files. So how do you, as you change configuration of an adapter or a validator or token manager, how do you do that? Do you go to that into console, export that configuration into your get, and then deploy it that way? Or do you modify the XML directly?
He did all that.
Yep, I know exactly the contents of all those XML files by heart. No, I do exactly that. I'll usually start it up running the current state and then go into the admin console locally on my box, make the change, and then export it and do a diff and figure out what needs to change and be checked into Git.
All right, Josh and John, thank you very much. Very good session. And thank you all for joining. The 3rd session in Identity at Scale starts in about 10 minutes at 5:25 if you're interested in coming back. Also, if you haven't already done so, please download the app from your app store. We'd like your session feedback, please. Thank you very much.